In this video, we will analyze these two irrational functions, and we will figure out the vertical and horizontal asymptotes, as well as any slant asymptotes or holes that are present. So, first of all, let's factor everything. I'm noticing that this numerator has 4 terms. Normally I would try to do grouping, but I see that I have a 26 and a 1 and a 4 and a 1. It doesn't look like grouping is going to work. So what I need to do is I need to put this into a calculator and see if I can find any zeros. So that's what I'm going to do. I'm going to go to my table function and type this in. So I have x to the third power plus 4x squared. So x to the third power plus 4x, whoops. X to the third power plus 4x squared minus x minus 26. So minus x minus 26. All right, I like to start at negative 10 because it rarely has to go past that. So I'm going to scroll down looking for 0 on the y side. All right, I didn't find any zeros, so this numerator is unfactorable. All right, that means that this x squared minus 9 is not going to cancel out anything. So that means there will be no holes. All right, so let's move on. I can definitely factor the denominator, and that's going to give me my vertical asymptotes. Are going to come from this. So if I set this equal to 0 and solve, that means I can factor this as x plus 3 times x minus 3. Setting these equal to 0, that's x plus 3 equals 0 and x minus 3 equals 0. That gives me x equals negative 3 and x equals positive 3. These are my vertical asymptotes. X equals negative 3, x equals positive 3. All right, now let's talk about horizontal asymptotes. Horizontal asymptotes are all about the degree. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is y equals a over c, where a and c are leading coefficients. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Okay, so which situation are we in? Well, the degree of the numerator is 3, while the degree of the denominator is 2. So that puts us in a situation where the degree of the numerator is greater than the degree of the denominator. So there is no horizontal asymptote. So for horizontal asymptote, we write none. Now, on the other hand, if the degree of the numerator is 1 greater than the degree of the denominator, then there might be a slant asymptote of the form y equals mx plus b. We'll find it using division, and it's important that there must be a remainder. Okay, otherwise that means somehow this did divide in evenly. So let's do our division to find the slant asymptote, because the numerator degree is 1 more than the denominator. So it's very possible that there is a slant asymptote. Okay, I'm going to have to erase this to make space. Okay, so let's get ready to do our division. So we are dividing x squared minus 9 into x to the third power plus 4x squared minus x minus 26. All right, so the first thing we do is we divide. All right, I'm looking at the x to the third power, and I'm looking at the x squared, and I'm dividing those two. That would just simply make x. So I'm going to put my x right here. I like to line up my like terms. Then you take that and you multiply using the distributive property. So x times x squared is x to the third power. X times negative 9 is negative 9x. Again, line up your like terms. Then we will subtract by changing the sign. So I'm going to make this minus, I'll make this plus. So now I combine like terms, so these cancel out. 4x squared comes down. Negative 1x and positive 9, that makes positive 8x. And then down comes the negative 26. Now it's time to start all over again. So again we divide. We divide this by this, all right, the first term of each. So we are dividing 4x squared divided by x squared. Well, the x squares would cancel out and just give me 4. So that is my next term would be 4. I would take this 4 and do the distributive property. 4 times x squared is 4x squared. 4 times negative 9 is negative 36, which I will put right here, line up the like terms. And then I will subtract by changing the signs. So this will become minus and this will become plus. These cancel. That leaves me with 8x plus 10. Now I'm already at the constant. That means this is a remainder. So this quotient up here is going to tell me the slant asymptote. All right, I'm going to ignore the remainder, and looking at this quotient of x plus 4, I'm going to write slant asymptote is y equals x plus 4. And that's it for problem number 2. Okay, let's do the same type of thing for problem number 3. Again, let's try to factor everything that we can. So let's see, I'm looking at the numerator. X squared can only factor as x times x. 4 is either going to be 2 times 2 or 4 times 1. Looking at the middle of 5, I'm going to go with 1 times 4. I know that inner plus outer must equal the middle. Inner, I have 1x because of these. Outer, I have 4x. I'm trying to get this middle of 5, positive 5. If I just leave both of these positive, that'll do it. So I'll leave this as positive and I will leave this as positive. All right, that makes 5, and positive 1 times positive 4 makes positive 4. So we have factored that completely. Now, looking at the denominator, first of all, I see a GCF. All right, there's a common factor here. So if I take that out, I'm going to leave myself the space here. If I bring out just the x, all right, dividing each of these by x, that gives me x squared plus 6x plus 8. All right, now I'm going to bring this up and put it here, but I'm going to factor this trinomial further. So I have the x, all right, but now as I factor this, x squared can only factor as x times x. 8 can either be 2 times 4 or 1 times 8. Considering the 6 in the middle, I'm going to go with 2 times 4. Okay, now again, inner plus outer must equal the middle. So inner, I have 2x. Outer, I have 4x. I'm trying to get a middle of positive 6. So again, I just need both of these to be positive to make positive 6. And 2 times 4 is 8. So that's how you factor that. So now I have factored everything correctly. Now, before I start looking at vertical asymptotes or anything like that, I need to recognize that these two factors are the same, x plus 4. So I'm going to cancel those out, all right? And that's going to produce a new function, x plus 1 over x times x plus 2. Now, when a factor cancels out, that's when you get a whole. So I know there's going to be a whole. Now the whole is going to be negative 4 comma something. Where did I get the negative 4 from? Well, imagine that you took the x plus 4 and set that equal to 0 and solved it. That would give you x equals negative 4. That's how you find the x value of your whole. Okay, now to get the y value, I'm going to use the remaining equation. So look at this surviving equation, right? Let's put this in our calculator and use it to evaluate the function at negative 4. Now, I mean, I could take this negative 4 and plug it in right now, but I think it would just be simpler to use the calculator. So we could make our little fraction, x plus 1 over x times x plus 2. All right, and I'm just going to use ask mode because I have a specific x value I want to see about. All right, and we want to evaluate the function at negative 4. So I could just put in negative 4, and it tells me that the y value is negative 3/8. Okay, so we found the whole. Let's see, what about vertical asymptotes? Well, remember that the x plus 4 canceled out. So that will not give us a vertical asymptote. It gave us a whole instead. However, I will still have 2 vertical asymptotes because we get vertical asymptotes by setting the denominator equal to 0 and solving. So that means I'm going to wind up setting each of these factors equal to 0. So that will give me x equals 0 and x plus 2 equals 0. So x equals 0, that's a vertical asymptote right there. And if I solve this by subtracting 2 from both sides, I have x equals negative 2. So that's another vertical asymptote. Now when it comes to horizontal asymptotes, it's all about the degree. As I mentioned before, these are the rules. All right, it's all about whether or not the degree of the numerator is less, equal to, or greater than the degree of the denominator. So in this case, I've got degree 2 in the top, in the numerator, and I've got degree 3 in the denominator. So the numerator degree is less. And if the degree of the numerator is less than the degree of the denominator, that's when the horizontal asymptote is y equals 0. So that's it. The horizontal asymptote is y equals 0. There will not be a slant asymptote because you're only going to have a slant asymptote when the degree of the numerator is 1 greater than the denominator. And that is not what's happening here, so none. And that is it for problem number 3.